important question in the basis and dimension. First, we need to find the basis and the dimension of the subspace of R4, the four-dimensional vector space, having all the vectors x, y, z, s of the format such that y equal to x minus z and s is equal to 2x. And then we also need to extend the basis to a basis for the four-dimensional vector space. So we are having the subspace having the vector of this kind and with these two conditions. So W is equal to x, y, z, s, the vector, such that y is equal to x minus z and s is equal to 2x, where x, y, z, s all are belonging to the set of real numbers. We can also write this further as x, y, z, s, the vectors, such that x minus y minus z is equal to 0 and 2x minus s is equal to 0 for x, y, z, s belonging to the set of real numbers. So let's take these two equations. So x minus y minus z is equal to 0 and 2x minus s is equal to 0. Marking this as 1. Now since 1 is a system of two homogeneous linear equations, in how many variables are there? 4 variables. So the number of free variables is equal to the number of variables, which are 4, minus the number of equations, that is 2. So this is equal to 2. And what free variables we need to choose? The variable whose coefficient is not equal to 1. So we can choose x, and also we can choose y. You can also choose z and s, right? The coefficient should not be equal to 1. Here I am having the coefficient of x to be 1, but in the second equation I am having the coefficient of x to be 2. So you can choose x, right? Okay. So choosing x and y to be the free variables. How to give values to them? Just write the 2 by 2 identity matrix. So first x is taking the value 1 and y is taking the value 0. And from these two equations we get the values of z and s. So for x equal to 1 and y equal to 0, we get from the first equation 1 minus z equal to 0. That gives z equal to 1, right? And for x equal to 1 and y equal to 0 in the second equation, we get 2 minus s equal to 0. That gives s is equal to 2. So for x equal to 1 and y equal to 0, we are getting the value of z to be 1 and the value of s is 2. Similarly, in the next set, x is taking the value 0 and y is taking the value 1. So from the first equation, we get for x equal to 0 and y equal to 1, we get minus 1 minus z equal to 0. That gives z equal to negative 1. And from the second equation, we get for x 0, we are having minus s equal to 0, that is s equal to 0. So for x equal to 0 and y equal to 1, we are getting the value of z to be negative 1 and the value of s as 0. So from these set, we write the basis. So from the first set, we write the first element of the basis and the format is x, y, z, s. So the value of x, 1, then the value of y, then the value of z, and then the value of s. Similarly, writing the second element of the basis from the second set, we have 0, 1, negative 1, 0. So these are the bases for the subspace W. And how many elements are present in the basis? 2 elements are there. So the dimension of W is equal to 2. Now we need to extend these bases. For that, we know that these two bases are linearly independent. And also these are the subset of four-dimensional vector space. Now because these bases are linearly independent, also the subset of the four-dimensional vector space, so these bases can be extended to form the basis of R4, right? For that, we need to find the generators of R4, right? So it is written that since these two bases is a linearly independent subset of R4, so therefore it can be extended to form a basis for R4. Now to get the generators of R4, we need to write the standard basis of R4 first. So that is 1 0 0 0 and then 0 1 0 0 and then 0 0 1 0 and then 0 0 0 1. So these are the standard bases of R4, right? So what are the generators of R4? These two bases plus these standard bases forms the generators of R4, right? So R4 is generated by the vectors belonging to the bases of subspace and also all these standard bases of R4, right? We need to write all these vectors in a matrix format first to get the bases of R4. So let me write this in a matrix form. And now to get the bases, we need to reduce this matrix into the row echelon form. Right? Okay. Please remember that while applying the operations, the elements of these two rows should not be disturbed. Right? Because these two are the bases of subspace, right? And we need to extend these bases to form the bases of R4, right? Okay. I'm having 1 over here as the leading entry for the first row. To make this your leading element, I need to make this element to be 0. For that, just multiply the row 1 with -1 and adding its elements to the row third. So row third is changed into 0, 0, -1, -2. So here all the elements below the leading entry is 0. So this is your leading element for the first row. For the second row, I'm having this to be the leading entry and I need to make this to be 0. For that, just multiplying the row 2 with -1 and adding its elements to the row 4. And row 4 is changed into 0, 0, 1, 0. So this is the leading element for the first row. This is the leading element for the second row. And what about the third row? In the third row, I'm having -1 to be the leading entry. But I'm not interested in the entries having the negative signs, right? So my first preference is to make this to be 0. For that, I take the help of the row 4 and let me multiply the elements of the row 4 with 1 and adding its elements to the row 3. And also to get 0 over here, again multiply the row 4 with -1 and adding its elements to the row 5th. So row 3 is changed into 0, 0, 0, 2, writing the fourth row as it is. And row 5th is changed into 0, 0, 0, 0, writing the last row as it is. To get the positive leading entry for the third row, where I'm having 0 in place of -1 now, right? Let me interchange the row third with the row 4th. So I'm writing the 4th row here and the third row in place of the 4th row. Writing the other rows as it is. So now I'm having the leading entry to be +1 in the third row, right? So now I'm having leading element 1 for the first row, leading element 1 for the second row, leading element 1 for the third row. All the elements below these entries are 0, right? Please remember, we cannot disturb the entries of these first two rows. These belongs to the bases of W, right? In the fourth row, I'm having 2 to be the leading entry. Let me interchange this row with the last row so that I can get 1 over here. So here I get 1 and here 2. Let's multiply the last row with 1/2. So I'm getting 1 over here also. This is your leading entry for the fourth row. I need to make this last element also to be 0 to have a beautiful echelon form matrix. For that, taking the help of the fourth row, multiplying the fourth row with -1 and adding its elements to the last row. So the last row is changed into 0, 0, 0, 0. All the elements below the leading elements are 0, right? So this is your reduced echelon form matrix. And number of non-zero rows are 4. And from these rows we write the bases of R4, right? Okay, so therefore, the bases are, from the first row it is 1, 0, 1, 2. From the second row we have 0, 1, -1, 0. These two are also the bases of the subspace W. Please remember, these bases should remain as it is, right? Okay, next. From the third row, we are having 0, 0, 1, 0, and from the fourth row, 0, 0, 0, 1. So this is a basis of 4-dimensional vector space, right? Which is an extension of basis of W. Alright, thank you.